Good morning everyone, I am Mr. Ish. Thank you for joining me for this odd functions video here. The concept of odd functions, just like the even functions, is not hard. You just have to know it. An odd function is that type of function which is symmetric. As you know, it has to have this symmetric but around the origin, alright? And in terms of graphs and in terms of coordinates, you very likely have the case where an x comma y and a minus x comma minus y type of coordinates are present on that function's graph. A good example is y equals x, and these graphs normally also go through the origin. See, 0 comma 0, here's your y equals x. It's symmetric about the origin. Anything you see over here is very well mirrored on the other side of the origin. How about this? Y is equal to x cubed, a cubic function. It is very well here going through the origin, and it is symmetric about the origin. You'll have a point here, x comma y. Here you'll have a point minus x comma minus y. And of course, for a limited domain from, let's say, minus pi over 2 to positive pi over 2, the vertical asymptotes, right, the tan x is also an odd function. It goes to the origin. You'll have an x comma y here, you'll have a minus x comma minus y, and it's symmetric about the origin. Keep in mind with these trigonometric functions, right, with the trigonometric functions, tan is an odd function, sine is an odd function, and likewise the reciprocal of sine, you can say cosecant is also an odd function. These are your odds right here. But with regards to the even functions, cosine and secant are even functions. You should know that. That's something you should just commit to memory. Let's look right here at the graph of the sine x. It would look something like this, going again through the origin, but you know it would continue here in this direction, it would come here. But it has a good origin symmetry. It is also, in another way, you can think of all of these as if there was like an imaginary y equals x line, right? If drawn properly, you'd have a symmetry around this y equals x line as well, simply because it's symmetric to the origin. But that's just an extra fact. Anyhow, these are your odd functions. There are many more. These are just some. What is the most important rule by which you can determine if a function is odd or not odd? Just like for even functions, there was that specific rule. Let's present you that rule for odd functions, and it is this. For any odd function which is f of x, the test is this: minus f of x should equal f of minus x. If this test holds true, then that function is odd. So that's what we will look at here with regards to our two questions. And we can do that very quickly as a practice. If f of x is equal to x plus tan x, and someone were to ask you, is this even or is it an odd function, or it's neither even nor odd, you would have to take it through this test. If you look at minus f of x, you would put a minus before everything, and what would you get? You would get a minus x minus tan x. If you look at f of minus x, right, you would have here a minus x, right? Then you'll have a plus tan of a minus x. You can take a calculator and take like a 45 and a minus 45. The minus 45 will make your value minus. So you'll have here a minus x and a minus tan x. This right here clearly mirrors that. So this here is an odd function. Keep in mind, tan and sine are odd functions. You can just commit that to memory. You wouldn't have to even go through this specific test if you didn't want to. If you have a question which looks like this: f of x is equal to x cubed minus sine x. Is this even or is this odd? Well, if you look at minus f of x, you're looking at minus of all of this, and you know what you will get. You'll get a minus x cubed plus sine x. Alright, now we'll compare that to f of minus x. You'll have a minus x, and you have cube, and then you have minus, and you have sine of minus x. Sine of minus x, take that on your calculator. Do sine of 30, do sine of minus 30. The sine of the minus 30 will give you a minus sine value, which will make this positive. You'll have a minus x cubed plus sine x. Compare these. This right here and this right here are the same, so this right here is odd. A quick tidbit information: if your function has a sine or a tangent and you have a polynomial with odd numbers, exponents, then it's going to be an odd function. If you have an even exponent function, like even number, like 2, 4, 6, 8, it'll be even function, or it'll spoil it. Our first question for this video is this: we have to classify this as even or odd or neither. A function is neither if it's neither even, neither odd. We know the specific test is always f of minus x is equal to minus f of x. And you have to learn all of this odd even functions generally really for calculus, because these applications come there. Anyhow, look at this, and you have 2x minus x root 5, and you're going to have minus 2x plus x root 5. And now we'll do the f of minus x. We'll do that. We'll do 2 times minus x minus x root 5, and you will solve this out. You'll have a minus 2x, and here you'll have a plus x root 5, and this is indeed an odd function. Why is this odd? Look at these exponents, they're to the power of 1. And I told you, if it's to the power of 1, it's generally going to retain the odd function character, so this question has been solved. Let's look at this question. We've added in a little bit of a twist here with a minus x. We have to evaluate this in terms of minus f of x, and then we'll see if this is odd, even, or if it's neither. And you're going to do the application of minus across this entire function. And what will you get? You'll get a x sine x minus 2, right? X sine x minus 2. Now let's do f of minus x. What are you going to get here? You have a minus x, you have a sine of a minus x, and then a plus 2. This here will seem to spoil it all because there's no variable attached. It won't change. Anyhow, let's look over here. We have an x. Here we have a minus sine x plus 2. We'll have a minus x sine x plus 2. And now we have to compare this with this. We have a minus x sine x plus 2. Here we have a x sine x minus 2. And it's not odd, that's for sure. But is it even? Well, we did f of minus x. Does this thing look like this right here? Does it look like that? It does. Minus x sine x plus 2 looks exactly like that. So we're finding out that this here is actually an even function. And that right there is the answer. It's not an odd function, but it's an even function. So this question has been done. Thank you for watching. Have a nice day.